I know I didn't have a chance to work that problem out in class, so I'm going to go through the problem. I'm going to show you what it really boils down to when we're solving these really coupled circuit problems. That, I'm missing a lot of people here.
Yeah. Yeah, let's do it.
Can we vote on it?
Yeah, let's vote on it.
You know, a lot of these guys do the great lawyers. The way to work with judge and everything. Anyway, what I wanted to do is go through this with you and make sure you see these steps. Because last time I didn't get a chance to put the matrix method up here. And I'm going to start by saying this. In general, when we have coupled circuits like these are magnetically coupled circuits. I got to tell you some things. This isn't coming out very well. To do and not to do. Those are coils. You're going to have a dotted terminal. You're going to have a current I1 into the primary. And then you're going to have a current I2 into the secondary. There'll be a voltage here. I'm going to do some problems, but I need you to be attentive here. Here's where people start really getting confused. Because we're going to use this with power. Here we're going to have an impedance at this side, right here, that is going to be given as like J omega L1. There'll be impedance here that's J omega L2. Now I want you to just understand something. If that's all the problem showed, then the voltage V1 would just be I1 times J omega L1. Does that make sense to everybody? That is if it's a non-coupled circuit. If this is just an inductor right there, then V1 is simply J omega L1. But there's more to this. Now there's a thing called a coupling impedance. It's called mutual, this is the mutual impedance, and that will have some value J omega M for the mutual. Or it could be L sub M. It means the same thing. The equations that govern these, and please listen carefully to this, because this stuff people get lost in it when they try to do it on their own or try to read on the internet, because there's so many ways of doing this. Remember, current enters the dotted terminal by the convention we're going to use. Just keep this in mind, you will not go wrong. You put your currents into the dotted terminal. If you're on the primary side, it's I1, secondary side, I2. Now the voltage V1 here is just like the voltage would be here if that was only an inductor. It would be J omega L1 times I1. That's the voltage due to just the impedance of that coil. But then there's a secondary effect where this current creates a magnetic flux that couples in there. And the way we write it is, we say it's also going to have an impedance J omega M. I'm going to use M for mutual. You could put L sub M, but it makes more sense here. M times I2. So that's what V1 is. So this current in I2 has an effect on V1. As a matter of fact, if there was no current in I2, if there was no load, then the voltage here on the primary side would just be J omega L times simply I1. Do you all see that, class? Because I2 would be 0. Does everybody get that? If I2 is 0, it's just like an inductor on the primary. Now V2 here is equal to J omega, and now you put the mutual in, M, because now we're on this side, times this current. It's the mutual times I1, plus J omega, and now it's going to be the self-inductance L2 times I2. Those are the relationships between current and voltage. I'm going to do the problem I started with, and I'm going to go through this, and I want you to work with me on this. I don't want to confuse anybody because people get lost trying to solve these all the time. I'm going to always set it up as a matrix. So in the book, the way I had this problem drawn, it had a source voltage here of 24 volts at an angle of 30 degrees. This is the problem I started with. And then you're going to have 2 ohms here. And then you're going to have the primary side of the coil here. The dot's here. Make sure you get the dot right. And there's going to be a J 4 here. Now that J4 represents J omega L1. So they don't break L1 out by itself. They give you the product of omega L1. And you all recall when you were doing problems before at constant frequencies, instead of giving you an L or a C value and asking you to create or calculate the impedance, they would say the inductor had an impedance of like J4. Do you all remember that? It's the same way here. This will be I1. Over here, you're going to have a secondary, and you're going to have I2 coming into it, plus the minus V2. The secondary has minus J2 ohms, and it has 2 ohms here. And what they want is, they want plus to minus V out here. And they're going to say that this is a current, I'm going to say this is a current I2. Now, I've got to caution you about one thing. In the book, they don't show I2 this way. They show I2 coming out. Do you all follow me on this? Immediately ignore that. Put I2 going this way. When we find this, the current in the other direction is just minus that. Do you all understand that? This is the sign convention we use. Currents go into the dot. Voltages are plus at the dot, minus at the other side of the coil. Now, when we do this problem, what I'm going to tell you the way to do this is probably the best way to do it. Start on the primary side, and then write a simple KVL, Kirchhoff's voltage law equation here. I'm going to do this slowly. I want to make sure everybody sees this. We'll set up the matrix and solve it. All right, ready? So when we do this, if I start here, and I'm going around the loop, I get 24 at an angle of 30 degrees. Do you all agree with that? Right? Now I'm going to have a loss. It's going to be minus 2I1. Do you all agree with that? And then it's minus V1. I didn't put V1 here, but this is plus to minus V1, and that's plus to minus V2. Do you all follow me? Do you all agree it's minus V1? Show of hands if you do. I need to make sure I've got your attention here. Right? It's minus that voltage V1. But what is V1? It's this. Got me? Now, what is J omega L1? That's J4. Do you all see this, class? The J4 represents omega L1. Understand, everyone? So I'm going to put this in as just J4. Right there. Y'all, can you read my writing? Is everybody good with this one? Now, okay? Now what about the next part? And it's going to be, it's minus this, but I'm putting this up here. What is J omega M? Oh, I didn't put it here. This is going to be J2, I think, is the problem. Yeah, it's J2. So this is J omega M. So now I get rid of this and just put 2 here. You all see what I'm doing? I'm trying to make sure you understand the relationship to the fundamental equations and what was drawn. Everybody good? All right, come on, be attentive here. Now, what's next? What about this one? What do I replace the omega M with? Just look at what's going between the dots. J2, right? So it's just 2. What about omega L2? Oh boy. And that's on me. This should be a J6 here. That's what I started with last time. I don't know if you remember, but that's J6, all right? You all follow me what I'm doing? Now just watch and you'll, yeah? I couldn't hear you. Did you have a question?
Yeah, talking about the angle for calculator. I think it's
An angle for a calculator? Did you say? If you have a problem about your calculator, we're going to have to take that outside of class. And if somebody can help me, please feel free to do it during class. But I can't deal with calculators right now. All right, now when we're doing this, so this is minus, this is where I'm getting to. It was minus V1. Do you all agree with that point? So what is V1? It's this. You plug it right in. Put minus the quantity V1, which is J4 I1 plus J2 I2. And all of this equals 0. Are you with me? That's the first equation. I'm gonna rearrange it. I gotta make sure everybody sees this. Are we all together on this? This is not hard to see, but you have to focus or you're gonna miss subtle things. You're gonna miss little things that'll drive you out of your mind. All right, now the next thing I do is this. I'm gonna take that 24 at 30 degrees to this side, all right, of the equal sign. But before I do, I'm gonna multiply through by a negative sign, because you know my passion of hating negative signs. So I'm gonna do that first. So I get rid of the negative sign. Now I take the 24 at an angle of 30 degrees to the other side. Got it, everyone? Please write these things down, these little things. So now this becomes 24 at an angle of 30 degrees on that side. And now, yes,
Why do you still have 2 up there? I thought we changed it to 6.
the 6 is what? For L2, JL2. This 2 is for M. This is for the, J2 is J omega M. All right, that's the mutual impedance.
Yes.
All right, I'm sorry, and please ask any questions, yes?
So V1 and V2, those are the voltages across the inductors. not
Across the
supports.
windings, yes.
Okay.
Call it the windings, not inductor.
Fine. Okay.
All right. How many have seen transformers? Raise your hand. I hope all of you have, really. All right, because this is really a transformer. It's a weakly coupled transformer like that. Like most transformers with iron car are strongly coupled, and I'll get to that in another later on in the lecture today, or probably on Monday. All right, now hear me now. What I want to do is collect the coefficients of I1. Can you all see when I collect these coefficients? I have 2 plus J4 times I1. Does everybody see that? I'll write it down there. So I have the quantity 2 plus J4 right here times I1. And then the coefficient of I2 is going to be J2 I2 is equal to 24 at an angle of 30 degrees. Please box that equation. Box that equation, put a 1 on it, number 1. Because we're going to reference this as for a matrix operation. Here your calculators are invaluable. You have to know how to use them. Everybody got that? Now, next what I'm going to do is write an equation around this closed loop. All right? Now when I do this, and I think I'm going to go I'm going to erase this for now. So around this closed loop, if you look at it, I'm going to start, this is my starting point, I'm going this way. You all see I'm going to have minus the impedance, and it would be 2 minus J2 times I2. Please watch this. I'm coming here, and I'm going to combine these two, so it's I2 times the sum of those two, right? That's a voltage drop. How many see this right here? Got to make sure we're together on this. Yes, sir?
So with these capacitors, do you not have to label the plus and minus side? Or do you
Remember, that's a reactance, right? What you have to do is worry about which way current's flowing. My current's flowing this way, right? Y'all with me? Current flows in the direction that establishes a plus to minus voltage there, where the impedance, it would be that impedance, which is minus J2 times the current flowing into it. Okay? It's the same way with any kind of impedance. It's always the current flows into the positive, labeled positive, negative term. Now, when I do this, I have minus 2 times 2 minus J2, and then I have minus V2, right? Please watch this. Minus V2 equals 0. Do you all agree with that? Right? I'm going to take, what is V2 going to be? Just look at it. V2 is that, isn't it? All right, I'm going to write it in the next line. Please watch this. And stay with me on this, because these problems are the ones where people start really getting dinged, especially when you get into power. They get clobbered right here. So now I have minus quantity 2 minus J2 times I2 minus V2. There's my V2. Put a quantity right there, and then put J2I1 plus J6I2 equals 0. Make sure you see what I've done. I've replaced the V2 with that. Correct? Now I'm going to group terms together. Most of you see where I'm going with this. I'm going to get 2 equations, 2 unknowns, and solve it. And it's going to be a square matrix. So here, I'm always put the coefficient I1 first and what's in front of it. So for I1, I see I have 1 I1 there. It's going to be minus J2 times I1. Y'all give me that? Right? What about I2? Well, for I2, I have minus J6, right? And then I have plus J2. If I carry the minus sign through so you can see it, this would be minus 2, right, and plus J2, right, times I2. Do you all agree with that? I just simply took the minus side inside. If I look at this, when I'm combining them, it's going to always put a plus sign, and then put the coefficient of I2. The coefficient of I2 in this case is going to be minus 2, right? Then a minus 2, and then it's plus J2 minus J6 or minus J4 times I2 equals 0. Box that equation, call it number 2. Got it? And you can see what I'm doing. I'm getting a square matrix. Now, some of you aren't used to doing this. I know that. But you're going to get used to it. Remember, these are complex numbers. So I have to instill in you the fact you have to know how to use your calculators with complex numbers. Follow me? The 83s, the 84s, the 89s, whatever, the 36x's and stuff like this. So what matrix equation am I going to solve? Well, it's this one. There's my first equation. My first coefficient is going to be 2 plus J4, right? Now my second equation, the second coefficient is J2. It's times a column vector, I1, I2. I know MEs and aerospace engineers are used to this. The IEs, I'm not sure if you're used to this or not, to be frank about it. The next thing, that's the first equation I put in row columns. Over here, I have to say what it's equal to. It's equal to 24 at an angle of 30 degrees. Everybody know what I'm doing, right? Simple square matrix is linear algebra, only with complex numbers. My next equation is this. So I put in, and by the way, you know, this is me personally. You do it the way you want. When I see that, I'm going to multiply through by a minus. All right? I don't like minus signs for a lot of reasons. So if I multiply minus 1 on both sides, do you all agree that's what I get? Flat? All right, now, what's my next equation then? It's going to be J2, right? And the 2 component is 2 plus J4. And this equals 0 on this side. Do you all agree with that? Now get your calculators out, see if you can do this with me. I'm going to erase this so I've got some room to operate. So this is the basic form that we talked about earlier, where you have AX equals B form. This is A, this matrix. This is B. And I'm solving for I, which is X. So my X is really my I1, I2 column vector, and it's equal to the actual A to the minus 1. This is how I do it. I don't know how you calculate this. A rise minus 1, and it's times B. And that will give you the answer. Does everybody agree with that? Now, could you give me the value, both magnitude and angle, of I1 and I2? And if you get it wrong, don't worry, I expect trouble. Remember, B is simply 24, 30 degrees and 0. You all see this, class? Please get your calculators out. Yeah. You got this, you might as well get them out. Warm them up, so to speak. All right, 24, 30, and 0, and there's your A matrix, okay? So tell me what you get for I1 and then I2. I mean, I know you guys know how to, you've got calculators. I know you guys do this. MEs, I know do this stuff. Aerospace for sure. IEs, I don't know exactly how much matrix math you guys do, but you normally, anytime you're doing a large scale processing problem, you put it in terms of matrices, and then you manipulate the matrices to for optimization. Isn't IE all about making money and optimizing? So obviously you've got to do something with this stuff at some point. Okay, what did you get? Now, if you're fumbling around your calculator, it's good. You're going to find out where your problem lies under these things. You have to do this efficiently, because the next test are going to be 4 problems that are all going to be pretty much all matrix problems, complex matrix problems. Anyway. Anybody got an answer for me? I'm not an expert at any of your calculus. I got an old HP, I just understand too. And I really like it because I can enter each one of those. I can put A11, enter, A12, enter, A21, enter, A22, enter. And just I can put it in, it's just really imaginary. So I got it all set,
These
yes.
again, don't you have to separate it into like individually?
Yeah, you have to do the
two
A minus B, B, A thing.
You have to transfer the complex matrix into a normal matrix, so it turns into a.
All right, I'm not expert, but that, listen, Isabella, is that, you put that thing up there on, if you take a look at what she posted on GroupMe, it's a,
Right, it just takes a minute.
yeah, and you should be able to do this. So what did you get, anybody?
I got 6.09 at an angle of negative 23 for I1.
6.09 at an angle of what?
Negative 23.7. And then for I2, I got 2.7 at an angle of negative 177.
That's what I got.
All right.
Nice.
How many got that? I'm actually not sure. Because I don't think they asked for that, but I think when I see a whole bunch of people getting the same answer, I think it's got a good chance of being right. Now, if you look at V out, what is V out equal to? Please listen to me. Here's where mess up happens. What is V out equal to? Just take a look at this and tell me. Is V out equal to I2 times 2? Yes or no?
No.
No. Why? Because that would be the negative. Then this would be plus that minus, right? It would be minus I2 times 2. So V out is minus I2 times 2. What do you get for V out then? These are typical mistakes. That's what I'm trying to clue you in on. What'd you get?
What's this matrix?
I want to know what this is. Minus I2 times 2. Anyone? Anybody? We got I2 right there, right? So multiplied by 2, it's twice 2.7, right? Right? It's 5.4, and the angle stays the same, right? And then we throw a minus, so it's minus 5.4 at minus 177. That would be correct. You all agree with that?
So you just took the magnitude negative because of
No, I mean, when you do this, a minus, this, just throw a minus sign in front of your 2.7. Yeah, that's right. You can do that.
So 5.36 at an angle of 3.5.
All right, 5.36 at an angle of what?
3.5. Is the angle supposed to change?
Well, it will, because what happens when you have a minus sign? What's minus 1? Isn't that 1 at an angle of 180 degrees?
Yeah, so 3.5.
So it will change then. Say again?
Yeah, so I mean, yeah, I got 5.36 at an angle
Of what?
at an angle of 3.5.
Anybody confirm that? Anybody else? You didn't get that.
Has to be exactly 180 minus that, right?
As far as the angle, yeah?
So,
Or plus that, plus or minus 180. I'll tell you what they got.
But I did exact numbers. I did 2.68 times at an angle of negative 176.
That answer's right on the board. 5.36 and 3.43 degrees is correct. You all understand the principle here? I'm trying to lay down some ground rules for you. What you do is do KVL equations around first and second loop, and then use the linkage, what V1 is in terms of I1 and I2. And you have to do this methodically every time. And here's why. Because you're going to look in the internet. I know, I always have people say, but I saw this on the internet. All right, the internet has a whole lot of different ways to do this with different standards. This is the common standard in real electrical engineering. Currents flow into the dotted terminals. The equations that I gave you, V1 is equal to J omega L1 I1, where I1's flowing into the dot, plus J omega times M, the mutual, times I2. Those are the standards. Now, you can do permutations of those things, but you'll get lost if you keep trying that. Stick with what I tell you, you will not go wrong. Yes?
Connor, with your question, going back to where you got your second equation, before you had negative quantity 2.
Well, this is the second equation right here, right?
Yes.
All right, start here and listen. Y'all agree it's a voltage drop. It's plus to minus, right? I2 times, so it's going to be minus I2 times 2 minus J2, right?
Yes.
Now put it right here. minus I2
I think it does, because this is 0. So it should-
times 2 minus J2.
I think it.
All right, now to this point, then it's minus V2, right?
Doesn't. I don't know.
All right, minus V2.
Let's see.
Minus, what is V2? Minus J2, right? Times I1 plus
Yeah, wait, let me see.
J6 times I2, all equals 0, correct?
Backwards.
You asked that, right? What's your question?
My question was how you came out,
Hey, guys, let me hear it, all right?
how you came to get J2 instead, there was a negative quantity 2 minus J2 and the 2.
That's right there.
disappeared. Yes, where did that 2 go?
No, it's minus 2, right?
Yes.
Wait a minute, where did it go?
Became the 4, yeah, pretty much.
When I take a look at this, this is the coefficient of I2, right? That's 2 plus J4, because I got rid of the minus sign. I2 is in the second column. All right, the coefficient's I2. All right, got it? Are you with me, guys? I want to do another one. Now, I know I didn't, I said give it a shot. Did anybody give that homework a shot in here? No? All right, well, I want to give it a shot now because where I'm going Monday is going to be tough. Yeah.
The V naught equals negative 2, I mean, 2 times negative I2, what? So we're solving for V naught.
That's what the problem asks for. You need the currents to get that though. And this is the thing, I'm glad you said it. The thing about these problems, no matter what they ask, the fundamental things you go for is I1 and I2. Now remember with mesh analysis, what did you want to solve for? Regardless of what was asked, I1, I2, right? With nodal analysis, you want to find the node voltages. So keep this in mind. This is like mesh analysis. You need the currents to get any other information. So remember that. Okay?
And where does that 2 is just the resistance?
Yeah, they wanted the voltage across that resistor, so we need the value of the resistance. That was it. Got it, everyone?
Why was it negative I2? Because we're at-
Well, all right. Can anybody answer him? Why was this negative I2? Just take a look at that.
the direction.
They wanted the voltage plus to minus, right? So I want the current flowing into the positive terminal. Right? That current would be negative I2. Can you hear me? Everybody see that? People, make sure you see this. I know there's a lot of chatter in here right now. I'm not going to break it up, but I'm trying to make sure you're clear on this. Yes, Elizabeth?
For the V2 equation, why is it multiplied by V or J6?
All right. You see right here, can you see this back there?
Yes.
That J6 represents J omega L2. All right?
Okay.
All right, now what is J omega L2? Well, when I add, I'm going to put this right here. For V2 in general, it's equal to J omega times the mutual times I1. Because remember, we're talking about the voltage on the secondary, so the mutual affects the primary current, plus J omega L2 times I2. That was J6. And it was stated in the problem. In other words, you didn't have to use omega times L to get that. It was a given.
Okay.
And that's something I'm trying to really underscore. That is given. If you look online, you're going to see that isn't given in a lot of stuff. In these problems, they'll give that. They're constant frequency, okay? Yeah.
Is the currents coming into the dot, that's a purely standardized thing?
That's the standard way of doing it. You have currents entering the dots, voltage developed positive at the dot, negative at the opposite. And I want to tell you this because this is a typical kind of question. Well, what happens if the dot's down here? No problem. Plus, minus. All right? That's what you do. No matter however the problem looks, the plus is always at the dotted terminal. The minus is on the other side. Currents always enter the dotted terminals. And I want to say this too, because some of you MEs are going to be seeing this kind of stuff. If you're working on Teslas or if you're working on any of the drones and stuff like this with a lot of really internal combustion and electrical power combined together, you're going to see possibly more than 2 windings. You may say 1 in the primary, 3 or 4 or 5 on the secondary. And you won't have just I1, you'll have I2, I3, I4, and stuff like this. And what happens is then that voltage on the primary is going to be J omega L of the primary times I the primary plus J omega mutual between this coil and one coil times the current really flowing in that coil. And you're going to get a system of equations where the matrices can be 6 by 6 easy, right? But by that time, you'll have somebody you'll have your instructors, whoever your teachers are and stuff like this, they'll go through and show you how to color problem apart and show you what to do at every stage. But they can get very complicated. This is a standard though. And remember, we haven't talked about power yet. This is just current voltage. Yeah.
My angle for I2 was like -176. So did you just add 180 to that angle? Now is that how you got through?
Now I gotta tell you, what did you get for I2?
My I2 is 2.6833 at angle -176.
Look at the arts. Same.
177. So you just added 180.
Well, I didn't just add, your calculators did, right? I mean, look, if you had, just listen to me now. If I put a minus sign out in front here, then effectively what I'm doing is adding a 1 at 180 degrees. It's just multiplying by 1 times 180. Because 1 at 180 degrees is just minus 1. Follow me? Or it could be 1 at an angle of minus 180 degrees. It doesn't matter.
Oh, so you're changing the current direction.
Yes. Remember the current was...
It's negative by 2, that's what it is. I got it.
All right. Yes?
Right now, are we completely gonna be dealing with an I1 and I2, or are we gonna get those up here and four up over?
No, we're only doing 2 by 2 here. I'm not gonna do anything beyond 2 by 2 for this class in a test or a quiz. All right, never. All right, because frankly, it defeats the purpose to use a calculator to solve it. The calculators are for small things. Anything big, you're gonna go to a computer, you're gonna pull out MATLAB or MathCAD or Mathematica or some, I don't know what, Python. You're gonna figure out some way to do it on a computer. Whenever you have large scale problems, you don't do those on a calculator. At least I don't. Here's one other tip for you writing programs, and a lot of you will be writing a lot of programs. Write notes to yourself in the programs, annotate it, make sure you tell yourself what in the world you're doing. Because people, I tell people all these, and they don't do it. I mean, graduates do stuff. Tell them, write a flow chart, show me the blocks of the flow chart, and then when you write the program, show me the block of the program. It's actually done by that piece of software. And then this, in the margins and stuff, make sure you make comments so you know what in the world you're doing and any problems. And you will be surprised how few get that through their thick heads until they blow it about 5 or 6 times. And then all of a sudden bells go off and they start realizing how far. I'm trying to tell you this because some of you people are, especially I can imagine IEs have these long giant processes you have to optimize. If you're going to PhD in I can only assume commenting will save the day in the long run. Now let's do another problem. That was a sort of a typical problem to get you warmed up. Now let's do something a little bit more challenging, or at least possibly more challenging. And here's a tip. Everything that you've learned so far is going to be used in the future here. The thing about it is the complexity goes up by an order of magnitude real quick. So I just want you to know that if you're not careful, you can get lost in the shuffle. I'm going to do 614. We're going to talk about it before we actually just go ahead and write the equation. We're going to use all the tools in our bag of tricks. The default unit are ohms, by the way, and then you got V1 down here. That's I1. All right, they want V out. You all see that? They want V out, well, this is gonna be I2, and this is I1, and here's the problem. Now, usually when you come up against this first time, you sort of, oh, what do we do? Now think back and what you're trying to do as engineers. You're trying to simplify the circuit as much as possible before you analyze it. Remember, the goal in this one, it doesn't matter what technique you use, what you're after is V out. That's the goal. So how do you get there? Now, think about this for a second. Does anybody see a possibility for simplifying before I just brute force and awkwardness do it?
Brute force.
Make brute force great. No. This time we're not gonna do it. We're gonna make it easy. How do we do it, guys? You're right, good for you. We're gonna do a source transform. See, I told everybody. You're right. Here and here, what do we do with that? Put a current source of 12 over 4, 3 amps in parallel with 4. Do you all see that? Let me do it right here. So now we got a current source right here. I'm glad you guys saw that. I'm proud of you. So we have 3 amps at 0 degrees in parallel with 4, right? And then what happens? It's in parallel with 12, isn't it? I'm going to put it here so you see it. I'm very glad you got that. I'm proud of you. And I didn't think you were going to get that.
Wow.
You all see what I've done? Everybody? Now, what happens there? 12 in parallel with 4. What do you say? You're looking at me funny.
The current for I2, shouldn't that be going into the dot?
Yeah, it should be going into the dot. Thank you. That wasn't intentional, but I do that every once in a while just to see if you're paying attention. That was an accident. All right, got me? Hear me. What is this? 3, isn't it? 4 times 12, 48 over 4 plus 12, 16 is 3, right? 3. Wonderful. So it's 3. Now we're not done, right? Because now we've taken these all into account. What do we do with this? We're not done yet. Back to a voltage source of, say it. What's 3 times 3? Plus or minus 9 volts, correct? Agreed? In series with 3, right? You all agree that that's what that would go to, class? How many see this right here? Let me make sure I'm talking to the right people. Y'all with me? I'm trying to do you a favor here. I'm trying to show you how to go about cutting to the chase. Because you're going to write, what people will do, we do this all the time. They'll put I1, or they'll put an I3 here, and then they'll try to get a 3x3 matrix. Don't do that. That's stupid. Make your life easy. I've taken this, these 2 terminals here and here are the same as these 2. So now I've got 9 volts and 3, and now I'm right here, right? Well, can I add that 1 to 3 and make it 4, class? How many see this? Right? Because right now I'm cut right there. There's a 1 ohm in series, right? Here, I've got 3 ohms, so 1 and 3 is 4. How many see this right here? Y'all see that, don't you? I don't want to raise my hand. All right, so I'm going to do this. I'm going to get rid of all that. And now I'm putting 4 ohms. And now I put plus or minus 9 volts. I'm having a great Friday. I haven't eaten lunch and I'm tired and my shoulder hurts, so I'm a little cranky, understand why. Everybody got that? Now, here, doesn't that look almost identical to the last problem, except the position of the dot on the other side, right? So we have to take care when we write our equations, we don't get the knee-jerk response and just write them the same way. We got to make sure we go in the direction of current. Yeah?
Do we need to change the value of the resistor?
I couldn't hear you.
Do we need to change the value of the resistor?
We did to 4. Remember, we had 3 there, plus 1 is 4. Isn't there?
Yeah, there was a 1.
Oh, I see.
There is a 1 in series.
Yeah.
All right, work with me, guys. What happens here? Now work at the primary side first. Let's do this equation. What do we get? We're going to get minus 9 if we start here, right? And I'm going this way, correct? Come on, work with me. Are you right?
Was it minus?
Well, because I'm going to, I'm sorry.
Yeah.
It's not actually. Plus
Okay.
plus 9, sorry. And then it's going to be minus 4 times I1. Y'all see that? Thank you. I'm glad you catch it. And then it's going to be minus V1, right? Correct? You see that's V1 there? So it's minus V1 equals 0. I'm going to put in what V1 is in a second, but I want to break it out by its lonesome. What is V1? Well, V1 is the voltage across there, right? Which is going to be J omega, or really J2. That's the impedance of the primary coil times I1, right? And then it's going to be, now take a look. Now you got the mutual here is J1, so it's plus J1, right? And it's times I2. Are you all follow me on this? All right. Now we're going to go ahead and put that in there. So I have, and by the way, what I'm going to do here, if you all don't mind, I'll take 9 to the other side, make it minus 9, and get rid of the negative sign, okay? So when I do that, I get 9 on that side. Everybody agree with that? I just moved 9. Now I'm going to replace V1 with that. So I got 4I1, right, plus V1, which is J2I1, plus J1I2 equal to 9, or combining things, I have 4 plus J2 I1 plus J1 times I2 equals 9. There's my first equation. Everybody got that? With me? All right. Now let's go around the second loop. Always go in the direction of current. You get your quiz in a second. So I'm going to go this way. With me? Are you with me? So we'll do it right here. Remember, for these upcoming problems, you got to use your bag of tricks and simplify if you want to get them done in reasonable length of time. So here, y'all see how this is actually plus to minus V2. Notice the plus terminal is at the dot, right? So if I'm going to go around, I get minus V2. Are you with me? Then it's going to be minus what? 2 minus J4 times I2, right? Equals 0. Does everybody agree with that? Right? Now what is V2? Well, V2 would be what? It would be J omega. Well, really, in this case, J2 is given. J2, right? I'm sorry, mutual. Okay, sorry. I want I1 here, so it's going to be Ji1 times I1. Now, I put the mutual term first because I want in the matrix first. I want the coefficient, I want the I1 stacked first and then the I2, coefficients I2 next. Got me on this, guys? Then I have plus, and now it's going to be the self-impedance J2 times I2. Y'all agree with that? Right? Now you put that in there for V2 right there, and I'm going to just tell you, can you all take that from here and run with it? You can put it in, right? Can you all get 2 equations then? With 2 unknowns, matrix form, you solve it. Once you have that, once I have I2, listen to me, what is V out in terms of I2? People, what? It's just 2 times I2, yes, that's it. And that's it, all right? Come on, Sabrina, you got this. Now it's quiz time. So do me a favor, spread out as much as possible. Everything off your desks.